You would like to know how to create your own battery model with the NGM200 and NGU201? In this video, you will see how this can be done. The main purpose is to gradually discharge a battery using the internal quick-up function. The discharge of the battery can then be recorded using the logging functionality. The recorded file can then be adapted to be used as a battery model in the battery simulation mode of the power supply. For this purpose, ROHDE and SCHWARZ provides a battery modeling tool for developers to make the work easier. Let's take a look at the way it works. First of all, it is necessary to understand all the important parameters. To build a battery model, 3 parameters are required: the internal resistance, the battery voltage, and the state of charge. The state of charge is defined as the level of charge of a battery relatively to its capacity in percent. If the battery, for example, is fully charged, the state of charge is at 100%. For the battery modeling tool to calculate the model, the open circuit voltage is very important. You can measure open circuit voltage if there is no external load connected. The internal resistance is quite constant until the battery is almost discharged. At that point, the internal resistance increases sharply. But how are the parameters of the battery model now calculated? The internal resistance can be calculated with the displayed formula. How do we now obtain these parameters to calculate the model? First of all, we need the open circuit and the load voltage. To get these, we need to discharge the battery in steps with the current you have chosen before. Then, we must let the battery rest the same amount of time. This ensures that the open circuit voltage can be determined after the battery is discharged. But how can this be implemented in practice? So, to get the open circuit voltage, we need to discharge the battery with a load step method. With the integrated quick-up function of the NGM or the NGU201, the arbitrary file can easily be edited in the arbitrary dialog of the power supply. Another possibility would be to create a CSV file. In the ARP editor, the file can then be selected via load from file. As soon as the button enabled is switched on, the function is activated on a respective channel and the arbitrary symbol appears on the screen. Once you have made the settings, you can save them and connect the selected cell to the channel of your choice. Using a 4-wire remote sensing setup will increase the accuracy of your results. But how can we record the battery discharge? The discharge of the battery can be recorded with the integrated logging function. Activate data logging and select an interval. Enable the desired channel to start discharging the battery. An automatic current range should be used for the measurement. The log file includes the timestamp of the power supply as well as voltage, current and power of the discharged battery. In order to employ the log file data as battery model, some computing effort is required. Store the log data on a USB storage and save the file locally on the PC. Before the tool can be started, some preconditioning is required. To run the battery modeling tool, a Python environment needs to be installed. We recommend to use the open source software Spider IDE. All required libraries are already included in this package. If, for example, you only use a Python idle, the libraries such as Matplotlib, SciPy and Python CSV still have to be installed. Once all libraries are installed, the battery modeling tool can be started. An Explorer window opens in which the relevant CSV file needs to be selected. Afterwards, another Explorer window appears where you have to choose the safe location of the generated file from the tool. Now the program starts and a plot is displayed, which shows the battery specific data like internal resistance, the battery voltage, the battery capacity, and the open circuit voltage versus the discharge voltage in diagrams. Finally, you get a CSV file, which contains the values of the internal resistance, the state of charge, and the battery voltage. This file is stored at the previously defined location. It is recommended to save the file directly on a USB stick. With the integrated USB interface, the stored model can be easily loaded from USB storage. In the dialog window of your power supply, you can activate the editor mode. Now you can select the battery file from your USB storage. The power supply loads the selected file into the battery simulation. The loaded parameters from the file are reproduced by the battery simulation. Now you can set the SoC with which you want to start the simulation of your battery. Connect the device and test your battery model. And this is how easily you have created a battery model. Thanks for watching and happy testing!